Oh, hello. Hi. Um, this is meeting number 3 of Scicloj, that group that has emerged in the last few months, where we are pushing forward the Clojure ecosystem for scientific computing and data science. And today we will have Martin Kavalar, who is already here, and we will talk about Nextjournal. Maybe just to let more people the chance to join, let us use these 2-3 minutes to tell about what we wish to do in the near future. So the idea is to create a group where we can think together about the ecosystem that we are building and hear stories of success, but also hear some thoughts about what is missing. And I think the story that we're about to hear today is of this kind, where it is already inspiring, but also may give some vision of what could be and is not there yet. And what we have done so far, we had 2 meetings about machine learning, and we have this very special meeting today. And then we'll have like a couple of meetings on the subject of interop in the next month. So we'll talk about interoperability with Python and R from Clojure. And afterwards, we are planning about 4 meetings of data visualization. And then at the end of the year, we'll have some probabilistic computing and other stuff of this kind. So that is the plan for now. But if any of you wishes to suggest a talk of your own and a subject that you feel is missing, then it is a good idea, and let us talk. And also today, after we'll hear and talk about Nextjournal, we will be able to talk about other stuff. So if any of you have a topic you wish to discuss for a few minutes, maybe a story of yours or maybe some thought about the future, then it is a good time to suggest that. So now I guess let us begin. So thank you, Martin, for being able to speak about this exciting topic, and let us begin.
Thank you. Trying to share my screen here. And do you see the slides? Yeah, all right. All right, yeah. So I'm Martin. I've been working as a developer since high school, so about 20 years now. I'm also the CEO of Nextjournal, where we're working on improving the workflow for both scientists as well as data scientists. And my workflow as a developer has improved dramatically over the course of these 20 years. Now, this is partly because I'm much more experienced today, but I think it's also because I have much better tools at my disposal. And the one tool I'd like to highlight is Git. Now, Git really has made experimentation for us as developers so much cheaper. Like branching that like on Subversion or CVS, which you might have been using before, like on bigger repositories was so painfully slow that you try to avoid it. Like I remember this taking minutes, and GitHub made that happen within an instant, basically. Or Git. Also, GitHub like did away with the one canonical source for a repository and made releasing small improvements to a library just so much simpler. It also helped like with the discoverability problem, like being able to put a small fix out there, seeing improvements that other people have made to the same library, and being able to like cherry pick what would fit your problem. And I think this like overall, like these 2 tools together have like led to an explosion in open source contributions and have made us much more effective as developers. But there's many domains like beyond pure software development, like where I think Git really isn't enough. And I'd like to look at a simple example first. This paper was published in 2014, is like a shining example of reproducible research. This means like the authors have tried to publish their whole methods and make it easy for readers to run them as well. And they are really following like what I think are best practices and using tools we as developers are used to. So they put their code up on GitHub. They even went so far to use Travis CI to ensure everything would still run after they made a change. But when I do try to run this on my machine, like here's the first problem I hit. This is like the first command that they're giving in the README. But yeah, for some reason, like the authors made some assumption about what should be installed on my system, but isn't, or there's some version conflict. I think you've all experienced this. Like we sometimes call this dependency hell, or Konrad Hinsen calls this the software collapse. And yeah, but once I do get past this problem and I do have managed to get further, there's more problems waiting. There's the problem of like installation as well as runtime. Like some of those libraries have to be compiled from source. That just takes a long time. And also when I do run the analysis, now this is a pretty simple example. This is just using the R language. But still this analysis takes 50 minutes to run from top to bottom, which I think is a long time to wait to get to some point where somebody else has previously already been before. But it's not always as simple as that. And I think like the more complex problems have again more problems. So to give another example, this was my diploma thesis that I did in physics. And I was working with the group doing bioinformatics, and my job was, I was given protein data from experimentalists, and first I had to like prepare those systems, which means like adding missing atoms, cleaning them up, and so I was able to finally run like simulations on a cluster of nodes. So I ran these like on the university high performance computing cluster on about 10 nodes in parallel. Then I had to aggregate this raw data, download it, process it, and do analysis on the resulting trajectories. Now this involved like both simulation software, libraries in different languages. There was Java, Python, as well as scripts to glue this together. And like I said, I was doing this on a number of different systems. So there's like the problem of already having run something, then trying to use this on another system. This often involves like manual intervention because these systems are different in unexpected ways. I think something you might also like experience when you do data science. Also, there's the problem of data management. Like the previous example had this as well, but here it was just on a different level where the raw data was in the order of magnitude of terabytes. And then there is a scheduling problem, like getting this to run on the cluster. These simulations, they benefit from having GPUs. And then like when time came up to start my write-up, there's a problem of keeping everything in sync. So I was starting the write-up already while there was still more data coming in. And like, yeah, keeping everything up to date, copying, pasting that from images like into my LaTeX and getting tables in there was just, yeah, pretty challenging. And also like collaboration, like, yeah, when time came to have my supervisor review my work, like emailing around the PDF and getting feedback this way, obviously also isn't, I think, the best way necessarily. So yeah, to sum up, like I think this is a list of problems that we might encounter when we do like science or data science. And I think like fundamentally these problems are the same in both domains. And But what if we could have a system like that would do away with a lot of these problems? And I think like functional programming and especially immutability is like pointing us towards a future where it is actually within our reach to fix a lot of those problems. Like, yeah, what if instead of struggling with this dependency management problem, we had a saner approach to this, and we're just able to like easily save whatever state we have, like share the complete image with others without having to care about like giving these images names and accidentally overwriting them later? What if we could skip this whole process of like rerunning stuff to just get to a point where somebody else has already been before? What if we could share this whole process state? And yeah, what if we were freed of having to pick names for files and everything would just automatically be versioned? Also, reuse could be a lot cheaper if we're working in a system that automatically records all our steps and makes it just easy to build on top of that. What if scheduling was just as easy as like selecting the machine that we want and having that automatically provisioned and shut down when we don't need it anymore? What if we could do away with the synchronization problem by having our final document that we create also be the thing in which we're able to run our analysis? What if collaboration was just as easy as inviting someone via email? Now, this is the stuff, yeah, I'd like to show you now, and we'll return to the example of the wood paper in a bit. But first, I'd like to walk you through like how some of the like we're definitely not there yet that we solve all of those issues, but I do think like, yeah, I can hint at how some of them can be solved. Oops. So here we are. And so just to give you an overview, like I'll walk you through some of the basics of like how to work with code and data in Nextjournal, like how we use immutability at all those different levels. Like we use like we version data separately from the notebook that you're seeing, as well as the computational environment. I'll also show you how plotting works and like how we can do easy automatic versioning as a result of these things. Talk about how to get data in and out of the system, and hopefully especially like our markdown export might be interesting to you. Give you a quick demo of sharing and collaboration, and then also like if there's time and you want talk about some of our vision, showing how we use bootstrapping and want to use that more in the future to build a system that's easily extensible and moldable to your needs. And yeah, if we do have time, also briefly look at like the Clojure tools and our Clojure workflow that we use. And to jump into this, I actually want to start also with a feature that's like basically the fruit of having this immutability at all levels, and this is what we call remix. This is analogous to like forking a repository on GitHub, and when I do press this button here, I immediately get a copy. The original document stays unchanged, and I'm quickly able to run code and make changes to this document without affecting the original. And yeah, we'll start with running a Clojure cell here. And yeah, first time I run this, it takes a few seconds to boot. Now it's starting to download those dependencies. As you see, generally code is executed here inside a runtime, which is a Docker container. And as you see, we have multiple of those here in this notebook. And yeah, we have like the whole app is written in Clojure as well as in Clojurescript. So we do have good support for all the Clojure data structures. And yeah, the second time I'm executing a cell here, it's nice and fast. We are currently working on some improvements for Clojure, mainly supporting datafy and nuff, as well as better errors. This is currently not quite ideal. Let me show this. Yeah, so we have this big long stack trace, but that should soon improve. But now back to the immutability. And so here you have a cell that's written in R. And again, like without us having to upload this data or provide this first, I'm able to run this and can start making changes here. Like if I want to look at the top 10 stations instead of the top 5, yeah, I can easily do that. And so, yeah, I've mentioned that when we do version like files separately from the container. And first, I'd like to talk a bit at how we do this. We basically currently take a SHA-2 of the contents of the file and then store it at this location. And like this way, we get deduplication of the content. So the same file is only going to exist in the system once. And as you see in this Clojure cell, we use base 58 encoding with a library called multi-hash that allows us to change the hashing format in the future. And so multi-hash is a library that it has like an identifier for the hashing algorithm that we're using in there. And yeah, we can make changes in the future and still being able to verify the hash. And I'm actually quite surprised, like we're using a pretty simple approach here. So far, all uploaded data and results are just being stored in one Google bucket. And that's been serving us really well so far. So the 3 years that we've worked on Nextjournal, yeah, we're still running on this single bucket. And yeah, that's actually not a whole lot of code to do this hashing. And yeah, I guess there's, it currently like the largest single file that we have, I think is like 100 gigabytes. So yeah, I think beyond that, you want to start looking at like adding mutable storage actually, but it is working well towards that sizes. If you want to ask questions like during the demo, that's also fine, please. Next up, I'd like to show you how plotting works. And we support Plotly out of the box, support for Vega, which a couple of you folks from the Clojure community have been asking for, is coming soon. I hope later this week or next week. And so we use like metadata, which allow you, when you're returning data from a Clojure cell, to select a different viewer. And I can also like, oops, this isn't quite working yet. I should be able to inspect this as data as well. We did make quite a few last-minute changes towards this demo. So yeah, I'm sorry if not everything is working perfectly here. And the next thing I'd like to show you is like how we're reusing, or how we allow reuse of custom environments. So environments is our term for being able to share a whole Docker image. And this is actually done across articles here. So what you see here is a Python cell, or across notebooks. What you see here is a Python cell that's using the SVG write library, and without having me to install it, I'm able to run the cell and start making changes here. And how this works. 1 second. So this is, Python is the language here, and this little badge behind it is a link to the environment, and the environment is actually provided by another notebook. And to see what this notebook contains, I'm just following this link, getting taken to this other notebook, and this creates a reusable environment. And this, in turn, we can again dig deeper and see what this is built on top of. This is using like our default Python 3 environment. Again, I can drill down deeper here. And so this starts with like a showcase showing you how to use the default packages that come with our environment, like Plotly, Matplotlib, stuff you might be using for visualization. And when I click down here on the setup, you can actually see how this is being built. So this starts by installing Anaconda. And again, I can drill down deeper here to see this is again built on top of our bash environment. And here this actually comes to an end. So this starts out by importing a stock Ubuntu image from this tag. And our Docker import works in such a way that you use the tag to specify the image when you import, but then this is imported in such a way that we only reference it by its content hash. So even when this tag is being renamed, reproducibility won't break, as this will be the exact same image. And another thing, so yeah, you can also see how this is being built. So time zones is being set up, some packages are being installed, locales are set up, and then we're doing configuration to ensure that GPUs work automatically with all our default images. And so if you're running on a machine with a GPU, we automatically mount the NVIDIA container runtime, and yeah, you have drivers set up, which yeah, typically is quite a pain if you need to do this manually. And yeah, I can now also, like, if you want, walk you through like yeah, how to create such a reusable environment yourself, or if you have any questions, you can start with those. All right. So I'm just creating a new notebook, like copying over this code. Like dropping in a Python cell here. Now, when I do run this, I expect this to fail because our default Python environment doesn't have the SVG write library installed. Right, so I'm getting this module not found error. And so there's one way to fix this. I can bring up the runtime settings and like import this from another article that's exporting this. And so I can already have a SVG write article here. And couple of seconds again. And yes, then I can run that. But now I'm also gonna show you, like, if this environment didn't exist yet, like how I would be able to create it. So I'm going back to the default Python 3 environment. We also have images for Python 2. If that's still your thing, or you need to run some old code that's still using it. And again, we'll get this error here. It should be the module not found error again. Shouldn't take quite as long. Let me try turning it off and on again. Sorry about that. One more time. Huh. All right, there we go. And yeah, so I'm getting the error again. So if we pretend this other environment to reuse it didn't exist, we can like add a bash shell here, do a pip install, and then we can run this. And it's running again. But this is, this isn't without a problem. So I'm not specifying a version here. So the latest version is being installed. And if I run this 2 months from now, I'm probably gonna get a different version. Now, not every ecosystem places as much value on backwards compatibility as the Clojure community. So yeah, there's a high likelihood that if you're using a lot more dependencies, that these things changing like that over time will lead to breakage. And so to save that and like save this exact version, all I have to do is bring up the runtime settings and check this export the environment box. Then this this prompt here pops up and it's asking me to review the changes, and I do see like a diff of the file system here, and I'm either able to save this image as is, or like reset this to its originating environment and run this from top to bottom. And this is, I think, also something that's typically pretty hard and finicky to do on your local machine. Like, yeah, you can do this with containers locally, but yeah, this resetting back to a known state, yeah, is pretty annoying oftentimes, I find. And so when I do press save here, we're committing the environment as a Docker image and are uploading it to our registry. And this is being stored in our registry. Again, we reference it by the SHA, and you can also go and pull this image to reuse it locally. And I'll show you more how that works in a bit. And actually, like one thing I forgot to mention, like there's a final step you have to do to actually reuse this. You have to publish the notebook, but we're working on removing that extra friction, so allowing you to reuse environments from notebooks that are still in draft state. And yeah, if you like, I can also show you how to use custom resources as well as GPUs. I guess let's do that here. So this is a notebook I created earlier today that's using the Clojure FX library. And this is actually makes use of the GPU. If I run this without one, it will complain about the display not being set. And like also like we're still running, our default Clojure environment is still on Java 8. So I'm actually installing, like importing OpenJDK 11 here, installing the lib OpenJFI library. And this also has, in the runtime settings, you see it has a more powerful machine than our default configured. So by default, we run on an instance with about 4 GB of RAM and without a GPU, but you do have the ability to attach different GPUs as well as, basically, like on our free plan, you're currently restricted to 15 GB of RAM max, but when you do join a paid plan, you can unlock these much more powerful machines. And as I run this, it takes like about 2 minutes to like provision the machine, and then in this case download the environment. But then I should be up and running here in a couple of more seconds. It's always a bit like, these estimations are a bit, there's some variance in this, like depending, I guess, how fast Google is able to provide those machines for us. And because this is quite a big environment here with X server and stuff, extraction takes like 20-30 seconds as well. And that should be coming up here soon. Right. So I'm able to run this, also add a bash cell and show you. Or actually, I'm afraid NVIDIA SMI, actually, because I'm, this is a problem because I'm starting here from this imported OpenJDK image. Actually don't have the NVIDIA SMI tool, but if you do run on a GPU instance with our default environments, this would all work out of the box. And the next thing I'd like to show you is versioning. So because we do have like all those things versioned separately, again, the document layer, then the data layer, and the environments layer, we're able to like show you the history, and you can like go back and also like restore previous versions. And like if we had the data just in the Docker container, which would also be possible, you would always have to like download and extract the whole image in order to like be able to see different results like this. And so I'm able to go back to the version that still produced the 3000 docs here and restore it. And the only thing that's like an exception to this is actually our secrets management. So we do allow you to create and reference secrets in those notebooks. I can show you how this works as well. So I can add a new secret here, or I guess and So this currently needs to restart the runtime. And then this is being set as an end var. And I'm able to access this. And this is like the only part, yeah, that's actually mutable. And that has to be mutable, yeah, because when secrets to external services change, yeah, you do want to be able to update them and reference the latest version. It doesn't make sense for them to be immutable. And they're stored encrypted in Vault. We're using like the HashiCorp stack. So Vault takes care of, yeah, isolating them by profile basically. And yeah, there's like an audit log. And yeah, things should be nice and secure. Feel free to ask questions. Also maybe put them in the chat. And next thing I could show is like, 1 second, importing of files. Just drag them in there. And then I'm able, again, to reference them. And this works like via this insert file menu. Like I said, this is because, yeah, this data isn't actually stored in the container, but is being mounted into it. And so like you see, I can access this CSV file here. And another thing I'd like to mention is our like results directory. This is like a special directory which you can write files to. And after every execution of the cell, we take any files that are there and put them into our content arrest storage. So yeah, they can be easily downloaded, and they're also part of the versioning here. And I can like switch to the file view and like actually download this file. And like you should see here at the top, I don't because there's the zoom bar here. But yeah, this is actually also content addressed like you've seen before. We also, yeah, trying to make it as easy as possible to get started. So if you're already a Jupyter user, you should be using our import feature. Here I have like a notebook on GitHub. Can just copy the URL. Paste this here. And hit import. And yeah, it's definitely not perfect yet, but I think it should be a good starting point. So if I'm lucky, and I think I am lucky in this case, because yeah, Jupyter actually doesn't like it doesn't have a way of specifying all the dependencies that this notebook needs to run. But in this case, like SciPy and sklearn, matplotlib are actually, yeah, part of our default environment. So I'm able to run these cells. And yeah. The next thing regarding importing I'd like to show you is Docker images. So you see here, this is our default Bash environment. But what I'm doing now is importing the official Bash image from Docker Hub. So I'm just hitting import here. Now this is going to Docker Hub, downloading the image, and again, checking, like resolving the tag, looking what the latest content char of this is. And to use it in this environment, in this runtime, I bring up the environments dropdown, can select this image now. And when I do rerun this, you see that we're now using Alpine Linux. And this is actually like, because all we need to execute like bash cells in these images, all we need is having bash be present there. This is what allows us to like do this sort of environments bootstrapping that you've seen before. So yeah, take these bare images and install stuff into them, which is something you couldn't do with Jupyter, where the kernel must be present in the image, which yeah requires like a whole Python installation, and obviously like yeah installing Python dependencies or upgrading a Python version from within this image is like a yeah shaky ground, and there's typically problems with managing dependencies in Jupyter like that. Another thing I'd like to show you is how to import repositories from GitHub, and we also have this small component here. Now this integrates with our secrets management. So I have my personal GitHub token here and should be able to clone this. To use it in this runtime, you also again have to add this as a mount, and this requires a restart of the runtime currently, and then I should actually be able yeah to browse this file, and I think I have it somewhere over here. Here it is. So you see, yeah, this is a private repo, and it does contain those files in it. And so by default, like when you work with it like that, this repository yeah lives on this instance that we've provisioned for you, and when this shutdowns after some idle time, yeah, your repository will, with all its like private data, will be gone again. And yeah, pretty much the same way you can also mount buckets, either from Amazon S3 or Google Cloud Storage. And here we have a like test bucket for this. Again, same thing. Add this as a mount, and can choose a destination, restart the runtime, and I'm able to browse this. So yeah, this is getting data, Docker images, notebooks, files in there. On the exporting side, we do support Markdown export, and so I'm bringing up the settings here. There's my Markdown export, and yeah, this file might be interesting to you. So what we're actually doing here, this is Markdown, and we're trying to make this as compatible as possible to like GitHub flavored Markdown. And to show you this, I'm actually pasting this into an issue here. So yeah, you see it comes out nicely. It even references the resulting images where that's possible. Here in the case of SVGs or images, and down here at the very bottom, we have like an Eden code cell that contains all the metadata that when you import this back into Nextjournal ensures this is still runnable. So this contains all the environment information and other metadata that you need to make it runnable again. And yeah, this combination of like, yeah, having Markdown as well as this like Eden appendix has worked pretty nicely for us. Yeah, in that we like typically YAML is used a lot for this kind of stuff, but then this doesn't support all the Clojure data types. Yeah, which would have been quite painful. And this gave us a nice and simple solution to support all the Clojure stuff we need while still having it be in a format where non-Clojure people can work with it. Yeah, getting data out, like I've shown you how to copy individual images. Like if you need to get more data out, I'd suggest mounting a bucket and copying that over here. I also shown you how to import or how to use the Docker, or I guess I can still show you this. So let's say you want to use this SVG write environment locally. Yeah, just copying this URL in here and bring up a terminal. And I'm able to pull this like on our public plan, which is like for open science, and these images are all public. Like if you do have a private plan, you can choose to make your images public or private. In that case, it will be only readable by you. And yeah, I guess one of the last things I'd like to show you is sharing. So we do have the ability to like share read-only drafts. Let me just put this into the chat here. So you should be able to, to have see this draft now if you follow this link. But I can also invite people as a collaborator, and I actually have multiple of my colleagues here, so can have common join. And like currently we have like a last write wins model on a per node basis. But this is, currently we're working on getting proper operational transform working. So pretty soon, I hope things should be working as well as what you're used to from Google Docs. Or is Dieter still here? I guess I can also invite David. Oh, there he is. All right, and thanks. So next up, I would, like I'm happy to take questions at any time, or like continue talking about like
so
where we
maybe,
want to go with this.
Martin, so maybe if it is a good time, then let us ask. So you're telling that so many parts of the system are immutable. So on the user side, code is immutable and data is immutable. But there is still something that changes, and that is the runtime, right? Of course, the Clojure runtime runs on the JVM, and we do not have an immutable representation of the whole runtime as a value. And then I wonder, is it a problem, the way you experience it, and whether you try or tried to cope with that? So I'm not sure if you wish to talk about it now or later.
No, sure. Yeah. So this is I guess down here. So yeah, I mean, anyone who's working with notebooks, and especially people collaborating on notebooks, like there's a huge hidden state problem, right? You define some variable at the top, and then you accidentally overwrite it at the bottom, and you need to restart your whole kernel and start over basically. I think this is a huge problem, and like Observable is, if you're familiar with this, it's this JavaScript notebook for visualization. It's from the people that also made D3, like Mike Bostock. And I mean, they have this, there you don't have any hidden state problem because they have a runtime. This is also open source. They have a runtime which handles this for you. So cells are referencing other cells, and you don't have this, like, you don't even, like, there's no notion of executing single cells, but you're just updating the notebook, and then everything is always up to date. And yeah, I think there's a huge opportunity there to also take this to more languages than JavaScript, and I think it can be done very well with Clojure. This is actually like what Matt Hubert has also shown in his demo. This is at px16.mat.is, which is like a beautiful data flow implementation in Clojurescript, and that also doesn't have these problems. That said, we also, like, when we started out, we also noticed that like, we try to put this like data flow like thing on these other languages, even with some very drastic approaches. Like, we would like use this checkpoint restore in user space to save the process state after every execution, and then cells could build on top of each other, but we could also always go back to a previous state. But yeah, this doesn't really work well for, like, I think like Clojure is also, like, the REPL-driven development workflow is teaching us that we can do a lot more things when we allow for these escape hatches and give the users control over when they want to run what. Like, I don't think you also want, you want to drag a slider and then some 10-day machine learning training starts right away. It's not always. So I think this visualization stuff, like the kind of things that Observable is doing, like when you're working on visualization, is really best suited for this. But I do think, there's definitely, and this is definitely something we want to look at to make that go to more areas. And no, I think that's certainly an opportunity. But like, we decided to, like, after quite some bit of experimentation, we started to say, all right, like, Jupyter notebooks are useful, people are using this pattern, and this is a proven execution model that actually works. So we start with that and then see where to take it from there. And I think, like, I do think it will be, like you say, there is mutability ultimately, like, and also in Python, which is the most popular language there. This is, of course, a lot more problematic, but I think, like, maybe a linter that or yeah, having some kind of linter that checks that you don't reassign variables, and also doing some AST analysis to automatically create these dependencies between cells, so stuff reruns or is kept up to date. I think could go a long way in helping people become more productive there.
Yeah, thank you.
And yeah, I guess another thing I'd like to share and talk about is like our vision of like bootstrapping the system more, so moving larger and larger parts into the system. Currently, like we do this with our default environments. So this notebook is basically the source of truth for our default environment. So the stuff that that shows up here in this dropdown, these selections that I get, they're all, if I do find this again. Yeah. So this is a notebook that starts with an explanation of the concept, and then here this is importing environments from different notebooks, and like to include a new environment in our default set, all we do is import another environment here. And yeah, like we hope that this like forcing us to use the system more and like using or building larger parts in it, will help us to build a better system and to build something more useful. And so we're already applying this to environments. Then we also have this thing we call a system process runtime. This is like what we use as admins. So you see here, this is only available to me as a Nextjournal team member. I have this system process runtime type, and this is, instead of connecting now to a plain Docker image, this is actually connecting back to our Clojure application that this notebook is executing on. And so this allows me to like, boot up this system that contains the datomic connection, and I'm able to like interact with the database here. And so we use this to like debug issues, and I think this is just a nice way to, the notebook format is well suited to that. So somebody inspects like an issue, you can link other stuff and like, have this history of what went wrong there. And when you want to do something similar, you can again remix this. And this is just a form, like for this kind of stuff, that's a nice form of reuse, I think. And like, or also like sharing small workflows, what you typically do in a scratch buffer. Like for example, this is like allows us to retract a profile handle when a user wants to change his profile name. Like we don't have UI for this yet, but this way we're just doing this over this notebook. And I think that's just, it's sometimes easier than having to, like you do something, like you connect to the production system to run something on your database, but then you don't commit it and share it with others. And I think, this can be a useful application. And also another thing to mention is like our, so we do have experimental Clojurescript support, but it's not useful enough yet to the general public, I'd say, as there's still, like, the main thing we have to work out still is like the security concerns around this, as you want to run on a separate domain in a different iframe, to not allow that you could read my cookies or perform requests on my behalf by sharing a notebook with me. But we have this editor process runtime, and so this is actually running inside. This is running inside the same process that our main app is now running in, and we think this could be pretty useful for debugging. I actually have the whole app.db I can inspect here. So oops. If I remove my auth token, which I shouldn't share, and we're experimenting with this, to actually build like when we had one bug in the system, like in the undo redo, this requires like a lot of we used the this runtime to like create a custom visualization for this problem at hand, and this would work similarly to what you see here. So here I'm creating through our viewers API that isn't fully fleshed out yet. This will still change in the future, but I'm subscribing to this node here and rendering a reagent component. So yeah, you can see this being reactive here, and yeah, you could imagine building other visualizations that look at some specific problem of your app state that you're trying to debug. And we can also drop this stuff in when we do have a problem in the current browser session. Yeah, I think this is also, can be useful. And also, like where I think this could go is eventually making this component creation like the GitHub component first class, allowing users to create them. And actually the code that's running, so this is basically something that's persisted in the document, and it has like a couple of, this is just basically a Clojure map with like the repository name, the reference if you fill it out. And what happens behind the scenes is actually also a notebook that's providing this code for the repository to be cloned. And this component basically passes a binding to this notebook and does the repository cloning and provides you like exposes amount that you can then add to your runtime. And we think, this kind of stuff, like trying to find the minimal abstraction, like, and having things go, through the file system, or being able to turn notebooks into like user-friendly components in the end, has quite a lot of potential in the future. And we're also using then notebooks to test this kind of stuff. So here you see a couple of different tests, like for this other notebook. And so what we're also working on is, on the bootstrapping aspect is, like, we're already running our continuous integration in Nextjournal, so we're using our infrastructure there. But like making all the things that are needed for this first class, so you can add an API endpoint to a notebook and have it like schedule more work. I think could be quite cool. Like especially like it's often, I think, frustrating having to go through these long feedback cycles, like when we constantly have to push something and then you're debugging some failure in CI that happens like I don't know, after 10 minutes or something into your CI run, when it comes to the point that it's that the failure occurs. And yeah, I think this could be like a smoother way to take to get to a certain point and then being able to abstract this and make it reusable. Yeah, I mean, we've talked about the hidden state problem. Another thing, like I think, which is a big opportunity down the road, is like adopting these more functional package management approaches. Like Docker is definitely problematic in a lot of ways. Like there's the black box abstraction problem. This is, I guess, more interesting to the people in science than to when you're applying it. But the one thing we all care about is that like downloads are often just like painfully slow, and the cold start problem is quite problematic. And having these more and yeah, nobody wants to wait for these long build times. And like these functional package managers, Nix and Gix, yeah, would provide a solution that like nobody would really have to build the same thing twice, and then you could just go and like have a central build server that shares the binary artifacts, and you don't have this problem that Docker has, like that like changing something at the top in the Docker file invalidates everything downstream and creates a completely irreproducible new binary blob that you then have to download again. And also lastly, I think, yeah, this is also this making the nodes first class in Datomic. Like currently our document is like a big blob that's updated through event sourcing. And I think that representing all the things that are relevant to the computation graph, like making them first class, could allow for some exciting different views into this thing. So you wouldn't have to always start with this notebook approach, but you could also, like currently this is hard for us to do, like ask, like give me all my files I have ever written as a from my profile, or show me all my environments and how they changed over time or something like that. And yeah, I think like for this, I think really Datomic is really great, and ultimately also I guess the like making the executions first class, storing them in Datomic, and yeah, providing you with runtime information about the past, like maybe also learning from that and auto adjusting resources, or like picking the right machine, or yeah, scaling resources accordingly to what we know about previous runs of the cell or stuff like that. I think, yeah, could be exciting. Yeah, if you have any questions, I guess would be another good point, good time to ask, or
yeah,
we can also talk. Yeah.
So Martin, if I may ask, then what you're saying is that notebooks are represented as data, and that this representation is accessible to the user, right? Accessible,
yes,
and understandable. And so
yes,
does it mean that users could potentially generate notebooks
yes,
by a program? You know,
yes,
that is a thing that I find really useful when generating Markdown-based notebooks, that I could create repeatedly many cells which are variations of something. So that could be potentially be done here.
yes, absolutely. And this is, I do think we have some like functionality around that. So I mean, this is like our like we used to call these things article, we're now calling them notebook, and we haven't renamed this consistently throughout the system yet. But for example, yeah, I guess we look at no. So these are this is like our current format. Like for example, you see like this being a code cell. So it references the runtime with this link. Like a node in our document is just a map currently, and like the section then has a list of subsections and content again. And I should even be able to, let's see this. So this is the paragraph here. Let's see if this works. So to let's see. It will probably go wrong, but let's try. Of course, not a function. Are we in the right? Well, whatever. This gonna. But yeah, we do want to enable this kind of generation, like have cells return data, like operations to change the document, and to create new documents and to execute them. And yeah, I think there's, yeah, like if you have a simple model for this, I think this, yeah, this could be exciting for people. Yeah, not so much interested in this. What you see is what you get interface.
Yeah, wonderful.
Yeah, I guess on the, like, yeah, if I should still share something about like our Clojure workflow and the tools we ended up with, or if you want to proceed to more of a discussion, up to you. How are we doing on time?
We do have time. I guess now we have 45 minutes till the official end, so we could do whichever we want.
Yeah,
and, it would be great.
I can do like. I think, yeah, it should be 5 more minutes or something, and then we can go into a proper discussion. Yeah, so like we started working on Nextjournal like 3 years ago. Like we started out with Elixir and Elm, and like it was sort of this like in Elm, like integration with existing JS libraries is really painful. Like you get all these great guarantees in Elm, like this really magic, like if it compiles, it runs, which, yeah, really is quite impressive. But yeah, when like here we have to integrate like with a ton of libraries like CodeMirror for the code editing, and yeah, this, like we're using ProseMirror for the rich text editing stuff, or content editable, and that's how we actually ended up with Clojurescript. So yeah, we didn't know anything about Clojure before, really. I think it had been recommended a couple of times to me, but I just looked at the syntax and yeah, always avoided it, and yeah, was quite surprised how, like, after really like being forced to try it, like how fast we were able to get productive in it, like, and the syntax barrier, which seemed so huge up front, really went away really fast, like within weeks. And I think like our main struggle had been with tooling. Initially, like, yeah, we jumped around quite a bit there, like started out with lining and then had like issues and thought switching to boot might fix them. But it was more that we didn't really understand lining in well enough at the point that we could also quote, use syntax quotes or in our project Clojure. And yeah, we finally, like, I think we invested quite a bit to make us productive, to become productive there. And Arne from Lambda Island really helped us quite a bit there. Like, I don't think we would have gotten up to speed as fast if it wasn't for his help. And yeah, the Berlin Clojure community generally has been, really great and helpful. Like, Matt is also part of this, and yeah, so we finally settled on tool steps as a build tool, which we're really happy with now. Which I think it has removed a lot of complexity for us and just given us a much more reliable setup. Also, like on the web server part or framework, we're using Pedestal, and like the interceptor pattern is like, once we were able to understand it, has been also like a really big win. And we're also using that to schedule the code execution. So when you're running a cell, we're looking at the state, and we have one first interceptor that's like doing the planning of the work that needs to happen. So this looks like, do I need to boot a runtime? Do I need to pull a Docker image? And then it enqueues other interceptors that are doing the actual side effects. And having this separation is great for testing. And also, yeah, it allows us to, it works pretty nice to have like these things like, all right, now the execution starts and I want to take the time it takes until it's over. So we have like an interceptor before and after the execution of each cell to do this kind of, and profiling. And yeah, also, like, I guess Datomic for us really was the reason to do the switch to Clojure, coming from Elixir. On the back end as well, like, yeah, it wasn't so much wanting to use Clojure at the time, but really wanting to use Datomic. I think, yeah, it fits us incredibly well. Like, for example, we have the goal of never breaking URLs. So when we rename something in the system, we want to be able to follow that. But it's obviously quite a bit of work to do all this stuff up front. And Datomic just gives us the peace of mind to do this, to always be able to recover any information. And I think the peer model is just incredible. Like, we're doing so much stuff in memory. Like, we're basically, like, we're storing snapshots of our document and then like doing roll-ups to get to the current state. And we're doing a lot of this just in memory without, like, we haven't really optimized much here. And Datomic really just does this for us so far. And even though we're not leveraging so much of it yet, I think it will become even more useful as we're making more things first class. But we're definitely really loving it. And lastly, like, Figwheel main on the Clojurescript side is something that we finally settled on we were quick to adopt when it came out, and especially the extra mains feature of it has been really cool for us, like allowing us to basically, like, we have 5 targets, I think now, like the web worker, like we had then the server-side rendering target and different browser stuff, and Figwheel main really allows us to yeah, basically only have one compilation process for all those targets. Yeah, reducing our feedback cycles quite a bit. I guess the last thing I'd like to show is like our REPL-driven development for Clojurescript that we're sometimes using. Sort of what you see here at the top is like this is on a pretty slow machine, so it takes like 5 seconds for a change to take effect after a live reloading, and at the bottom you see how fast this can be when you have it reload at the REPL. So we have like a small Emacs, like we allow you to opt out of live reloading in the Clojurescript REPL, or in the Clojure REPL. So you turn figwheel live reloading off, and then we have a key command in Emacs to like evaluate the form you're in and send like a reload command to figwheel. And yeah, the result is that you see the effect of a change after like 0.1 seconds instead of having to wait 4 on a slow machine. Yeah, I think that's everything I have. Maybe one final note. We do have the Woody analysis, the paper I talked about before, online as well. You can check that out here. Yeah, it has some interactive graphs like with Plotly that you can inspect and stuff like that. And yeah, I think that's all I have. Thanks a lot.
Thank you, Martin. Thank you so much. It was a joy. So now we have time for questions of anybody, and I guess it could be nice if we could keep talking about Nextjournal for a while, and then keep some time for the broader discussion of anything else that anybody here may wish to talk about. Does anybody want to say anything or ask Martin? Yeah, so I'll ask one more question. So I guess it could be nice to hear what was difficult in the development process and what is difficult now, what you find like an obstacle that you find hard to fix in your development. Is it a good question?
Let's see, what do I find hard? I mean, yeah, especially like, I guess coming from Elm, I do sometimes wish there like this, yeah, this way the Elm compiler can be helpful for you in like catching errors up front. That I think is definitely something, yeah, I sometimes miss. And I think, yeah, like maybe like this gradual typing stuff like can be could be useful there for us, like that I think Ambrose is working on making easier with spec. And I mean the main thing for us, I think what's been difficult, like yeah, we struggle a fair share, like I think with the tooling, and things are settling down there, but yeah, it definitely still is a problem. Like I guess also this, yeah, like when you want to run on these on different targets, there's always like slight like I guess like before I was doing Clojure as well, I thought like having this this one language that like Clojure and Clojurescript that you can reach into both the browser and the JVM, like I think before I did it, I imagined it would be easier to share the code across these platforms. I guess that's also like a consequence of the tight host interop, right? On the one hand, it's really great because you are so close to the target platform, but then when you do want to share stuff across it, it is quite a bit more work, and there's also like subtle differences between Node and like Node as a target, and then targeting the browser and stuff like that. I think that's a main area where we're struggling with, and also like I guess JavaScript dependency, dependency management, definitely one of the hardest problems. You have it everywhere, and also on the JavaScript side, like we're just starting to to split up our bundle more, like doing lazy loading of some of the, because we do integrate with quite some big libraries, like Plotly comes with its own D3 and stuff like that. And I guess, we've also struggled to get advanced compilation working. We haven't been near that at all. Not sure if we'll, if we ever will get there. That's also like a bit problematic because of this editor Bootstrap runtime that I've shown. Like if you would, like you can't really optimize the names away for this, or so it's limited to what you can optimize and have that working. But yeah, that's, I think, also definitely been a struggle. Yeah.
Thank you. And I guess maybe it could be nice to talk a little bit more about your client-side stack of libraries that you like to use, if you wish to tell about that. I think I once heard that you began with Reagent and then went to Ohm, and then I guess went back to Reframe and Reagent.
The Ohm thing, didn't really happen in the end. So yeah, we started out with Reframe, and like that was which I think is the closest to the Elm architecture. They're, I think, quite similar. I think this was like when we started out, like coming into the Clojure community and like learning about like this, like with Elm, it's totally like there's no choices to make for anything in Elm. Like you have the Elm architecture that everybody's using, and then you have one library that does one thing and it has the name of what it does. Like Elm HTML is your HTML rendering library, and like coming into Clojure as an outsider and beginner is quite a bit different. Like you have all these choices to make, which I found incredibly tough at the beginning. Like, and they all feel like very fundamental, like very consequential decisions. And then so we were starting out then. Like then asking Matt like what he's using as a framework, and he's written his own thing, of course, because like he said Reframe didn't perform well enough for his use case, and Ohm didn't either, and then there's Precept coming out, which I think it's like I do think it's like Reframe has now like it served us incredibly well, and I'm also really I'm surprised like how easy it is in the end in like coming from other languages. These like maybe, yeah, what I just said is a bit untrue as well, because these decisions aren't as consequential as you're used to when you're settling on a framework in these other languages, right? Because when you have then a specific problem that Reframe doesn't solve for you, you can also like combine it with the small other library or the small other thing that you've written to make it do what you want. And yeah, so I think that's rather gonna be our approach rather than doing like this big switch again to something else.
Nice. Yeah, it does make sense, I guess. Anybody else? Any questions? Yeah, so I think maybe one topic we could discuss here is the potential relevance of Nextjournal to this community. And by this community, I mean the several dozens of people who come to these meetings and are creating Clojure libraries for data science and Clojure tutorials of data science. And actually, in the last few weeks, several community members were creating some beautiful notebooks in Nextjournal that I like to read. And so far, there is some joy around it. And I wonder, it could be nice to hear your vision of the relevance of Nextjournal to open communities, to communities where possibly most members do not have an account, or I'm not sure the way you think about it, and how it could be still useful for people who are trying to share their work and learn from each other. Is it a good question?
Yeah, definitely. I think, yeah, that's certainly something like we think about a lot, and I think this was like maybe the most brilliant invention of, or the most brilliant idea behind GitHub. This like their URL structure and the way they put the like profile and the code front and center. And like, yeah, when you compare it to SourceForge, where it was really yeah, a pain to get to the code, there was all this other stuff like clogging that up. And like I would love to see like code being runnable without a login right from the get-go. And this is a lot easier for client-side code that executes in the browser, where yeah, you don't have the problem of who's paying for the compute. But yeah, I like ideally, yeah, we find some way to make that work. Like yeah, we can. So there, the idea would be similarly to GitHub to yeah, do a lot for these open communities while being able to finance that through like people using the thing in private. But I think like tearing down this wall between like who's the author of something and who's the reader, and because like being able to play with stuff and experiment in order to better understand it, yeah, is really crucial. And yeah, we want to tear down this wall as best as we can.
Yeah, so in a sense, maybe the question is, what would be the equivalent of the GitHub clone button, right? What would it mean for a person to clone an external notebook to their own machine and play with it, right?
Yeah, I mean our remix in some ways is the equivalent of fork, but yeah, I mean, like regarding this being able to work locally, this is also definitely something we want to enable. But for now, like our focus is on providing a really good user experience online, and then tackling this like local problem in a second step. But I do think like a lot of the technology is also starting to appear and be there, like how you can transfer like content address data with like trustless. You only need to know the hashes of things, and then you can like verify that you're getting the right data. And yeah, applying this, I think would enable, could enable this being able to, like, again, this is immutability, like IPFS is using it, or Merkle trees, that could enable this pretty fast local workflow as well. And yeah, that's definitely something we'd like to do when we get around to it.
Yeah, and Martin, would you like to tell a little bit about your work on different languages? I mean, one interesting question would be your efforts in making everything work with Python and R and Julia, I guess. What was difficult? What took a lot of work from you, and why? And another question would be, are you thinking about interoperation between the different languages, or what ways can one use to share data between the different runtimes?
Let's see if I can maybe show something, but I don't guarantee that this will, or no, let's better, it probably won't work well. So we, this is actually like, when we started out, we thought about cells as being more this, these referentially transparent things that return a result as data. And so then other cells could reference the results of them and have basically this. So you think of being able to create these kind of marks also for referencing other cells' results. And then, or I think, 1 second, Siri just activated itself. 1 second. And then having like a small layer that basically like encodes this to some data serialization format, maybe JSON, maybe transit, maybe CBOR, and yeah, that being transparent to you as a user. And I think, yeah, that can go, yeah, can go quite a way. But yeah, the devil is definitely in the details. Like, you will often encounter things that don't fully round trip between those languages. Like, you can make this work for Clojure very nicely, but yeah, as you're dealing with stuff yeah, in Java, or that's not pure Clojure, these things start to break down. And I think this was also our learning experience, definitely, to like focus on something where, like, have a proven model and yeah, start out with this thing we know that works, and like take a second step in trying to yeah, improve the, yeah, like how the whole system works, or the I guess the programming model behind it. But yeah, that's definitely something we do want to look at. And I do think, like, for, yeah, of course it depends on like how large the data is and stuff, but I think, yeah, being able to, it's already going to be valuable for like basically setting parameters things and stuff like that. If you can do like interop, yeah, between languages there, this can already be quite useful, I think.
Yeah, beautiful. And I guess so. Martin, is there anything else you would like to talk about regarding the future vision of Nextjournal? Or
no, I think that's it from my side. Yeah.
Okay. Yeah. Yeah. Anybody else? Anything? Any topic you wish to discuss? Great. So I guess if that is okay with everybody, then let us use the last 15 minutes to discuss some other stuff of this community. And Martin, thanks again. It was really a pleasure
Thank you.
to hear
My pleasure.
everything about Nextjournal, and I look forward to use it more and in the future. And several people here could not join this meeting today, and they asked for the recording, so everything will be recorded. And maybe I'll tell just a little bit about the other stuff that is happening. And so, like I said, we are planning a series of meetings of this kind, and the topics of the near future will be interop with Python and R mostly, and then a series of meetings about data visualization, and then some meetings about probabilistic computing and the so-called probabilistic programming. That will be around October, I guess, if we manage to squeeze everything. And this group, Scicloj, is doing some other stuff. We are, in a sense, supporting each other in the open source libraries that we're writing. And most of the discussion happened in the Zulip that some of you may know. And also, what we began doing is the work on tutorials, because we figured out that somehow if we wish to build a better platform for data science in Clojure, then we need to see how easy it is now to teach what can be done, and to see what cannot be done at the moment. And so several of us began working on tutorials, and then some use Jupyter, and some use Nextjournal, and some use R Markdown. And in a sense, we are trying to converge to a way that we can share tutorials with each other, and there is a small team of people thinking about it. So if anybody here wishes to be involved in that process, in the thought process of creating a community that creates tutorials, then let us talk. And another thing that will be very soon is a website for the Scicloj community. And another thing is a group of people who are thinking about the more general planning of what this community does. And everybody are invited to take part in these processes. And so if you wish to get involved in community building, then let us talk. And another thing that we are beginning to do is so-called interviews, where we have meetings which are typically smaller than this one, and we talk about a certain person's workflow working with data, and that person will show their own view of how they like to work, and the other 2 or 3 people in the room in the meeting will ask questions. And we're planning 2 or 3 interviews of this kind in the next few weeks. So if any of you would like to share your ways of working with data or doing visual stuff, then it would be beautiful to interview you. Does anybody want to ask anything about it? Okay. So I guess
on the tutorial side, I think that's that's definitely also something like we at Nextjournal find interesting. Yeah, and also like making this improving the interoperability like of the stuff. Like we're also thinking about GitHub integration, or like making README or tutorials runnable. And like there's I think what shows the most promise there currently like is like Julia. There's this Documenta JL project for Julia, and this already like they basically have all the infrastructure in place to like have markdown files that contain runnable code cells, and also allow you to like control like which part of the cell you want to show, but have the whole thing be runnable as tests basically. And maybe creating such a thing for Clojure as well, like with readmes or tutorials. You typically, like when you do more complex stuff, you often have the problem that you don't want to show everything. You need to set up some state, right? Following the stuff from a tutorial one by one isn't always gonna be runnable. And Julia has a pretty nice solution there. Maybe doing something similarly for Clojure, could be something. I mean, and also if we're like, I guess if we're just we're just talking about Clojure, like also how Maria is like allowing their exports of the stuff being Clojure files with markdown comments, basically, could also be a nice thing. Maybe that's definitely something we're interested in maybe collaborating on.
Hey, it's Jeremy here.
Hey.
If you don't mind me interrupting. So on this tutorial thing, so I look after Crux. So I did the bitemporal tail Nextjournal thing, and I created another one on Friday. And again, it's like really quick and easy to do. So we're thinking at Juxt to sort of double down on using Nextjournal as like a mechanism for doing these Crux tutorials, which admittedly like aren't necessarily oriented around data science, but obviously it's data management. And I guess I just wondered what you thought of that. I didn't want to like abuse your intentions for Nextjournal, but I imagine like instead of using CSV files or whatever to push data backwards and forwards, if you had these like standalone mode Crux instances as like the data format within the notebook, that could be kind of interesting, I think, for everyone in the wider community. I just wanted to.
So I think like that's definitely not a like I really like the Crux tutorial you've put together, and like that's definitely like not a abuse of our system. I mean this like being able to explore stuff like that, I think it's a great use, and especially like like this kind of stuff where you like maybe need to start a server process as well, and this is things that are, I think, often like painful to get to a point where you can play with it, right? You need to load the data in, and so that's really great to hear that you're thinking about working like using this more, and please let us know like anything we can help to make this better for you.
Cool, I appreciate that. Thank you. I mean, I guess in particular, like we're really interested in expanding outside the Clojure bubble with Crux. Like we really want to get people who are in the same way that you wanted to use Datomic, so you had to use Clojure. We want people to like want to use Crux who are scared of Clojure, and so you want to make it as easy as possible to get going. So not having to have Clojure installed locally is like a really big deal. Okay, so great. We'll stay in touch then. Thanks.
Crux is also like when we're like we're thinking of like what can we do, like what can we use instead of Datomic to like provide people with a local installation. There's Datomic free, but Crux is definitely something we're also looking at there.
Good to hear. Well, get in touch if you have any questions, anyway.
Yeah.
Yeah, so like you said, there are some pain points in doing tutorials nowadays, and one of them is having to run locally, which is sometimes a necessity, and what we run into when trying to create a Jupyter tutorials is many times the problem of depending on data. And actually, to be able to run a tutorial, one may need to have all the data just in place for everything to run, and that is a bit tricky to automate. So that is why that is another reason that it was interesting to see the elegant solutions today. And like you said, there are many opportunities here. One of them is connecting documentation with tests, and there are several interesting libraries here in the Clojure ecosystem. I enjoy using the HA test library by Chris Zeng that helps me a lot to generate documentation from tests. And then there is a question of whether all these opportunities play well with each other. And at the moment, not yet. And it is a question how to make these things converge. So one thing that is important is a standard data format. And it seems that many tools are converging to Markdown, to several variations of Markdown. And the question persists, how we may connect everything. And I think we are not there yet. And I guess Nextjournal has its own data format for representing notebooks, but you already took care of importing it from Markdown, right?
Yeah. So yeah, I mean our canonical format is basically Eden, but yeah, we're trying to trying to make this as lossless as possible. Like Markdown, I guess the deeper you go into it, the messier it becomes, right? So it is quite a tough problem to make it work really well. Like I guess on the data exchange, which I think CBOR looks pretty promising. Like if you're looking to share data, this is what IPFS uses behind the scenes as well, and there's also IPLD, which is their data model built on top of CBOR, and this pretty much, like there's also like good Clojure libraries for this, and I guess like IPFS or something similar would like could solve this like getting data locally problem. I guess another, like what we're also thinking about like maybe is having this like file system that you mount where what was this, like there's this Clojure is capable tutorial where he talks about like getting a fuse file system working in Clojure with the libfuse API. Maybe having something like that where you can can run this process locally and have this mount some file system over the web could be a good solution to enable this like data sharing locally problem. I mean, IPFS is also like, I'm not sure how, like there's definitely still it's not a perfect solution yet. It's I think quite painful to use in some cases, but yeah, maybe it is worth giving it a try for this kind of problem.
Yeah, thank you. It is really eye-opening, and I guess we will have the opportunity to play with that in the next few weeks, working on tutorials. So I guess we're close to the official end of this meeting. Does anybody else wish to say anything or ask anything? Okay. Any concluding remarks, Martin, on your side?
No, I think, yeah, that's it. I've talked enough. Thanks a lot, everybody, for joining.
So thanks again.
And yeah, thank you a lot for putting this together. I think it's great that we're having this conversation. And yeah, we'll definitely also join the Zulip.
Yeah, so it was a joy, really fascinating, Martin, and thank you everybody for being here. And I know that several people are waiting for the recording, so it will be up in a few days.
I guess, yeah, if I may make a final suggestion, you've mentioned this as well, like, yeah, would be nicer if more people turned on their video as well, right? So that you're not talking to these black boxes for next time. Yeah. All right. Thanks, everybody.
Thanks, everybody, and see you soon. Goodbye.
Thanks. Bye.
Bye.